Hi, Chem 151 students. Just wanted to give you a video to kind of walk you through some of the things that are described here in experiment B, and make sure you're be able to do that okay. Of course, if you have additional questions after this, you can ask me. So the point of experiment B is all about learning about Excel. So a lot of our experiments that we do later on will require the use of Excel, and so you'll want to get comfortable with it. I do want to mention that you're going to want the desktop version of Excel. There is an online version, but it's not as good. And so you want to make sure that you've got that desktop version here. If we go into the Canvas, hopefully you guys have already downloaded that. I suggested to you to download it in the first week, but again, you can get it through the SBVC Student Resources here, Office 365. You will log in as it says on the instructions using your student information, and you're going to want to go to up here, Install Office 365 Apps. You don't want to use the online one like this. It's just not as good. There's some features that just aren't the same online. So I highly recommend, you probably could finish it without the desktop version, but I highly recommend using the desktop version here. So now I'm going to kind of just walk you through what must be done. So as it says here, if you want to do anything mathematical, you press an equal. Like if I do equals 3 plus 5, it will give me 8 in that cell. So just typing equals starts a formula in Excel. So another note is that when someone is describing a graph, they usually say you graph the values of what's going to be on the y-axis versus x. But in order to, when Excel is making the graph, it assumes that your x values are going to be in the first column and your y values will be in the second. So that can be a little confusing, but just keep that in mind. And so we should all be using the same version of Excel, but if you're using a different one, things do look a little bit different. So that's something to keep in mind. And so here are a few examples of formulas. I'll show you the ones that you're going to need as we move forward. So let's look at, for example, here the part A. So this would be like if you weighed the same thing over and over and you got different weights. They're very close to one another. And you want to calculate some various types of statistics for this set of measurements, which is very common. So when you label this, whenever you put a label at the top of a table like this, you're going to want to put the label of what it is and then put the unit in parentheses after. And then you could put a numbers of units here, or sorry, number of measurements, 1.236. And as long as you've got the units mentioned above, you don't need to put the units here. In fact, it's probably better if you don't, because then the Excel will read the number as text instead. Right now, it thinks that it's a number. I do want to point something out. For numbers like 1240, Excel will take off the 0. So Excel it does not really know about sig figs unless you tell it. So for this entire column, what you'd want to do is make sure that it knows that these are numbers. So you can go up here and you can tell it that it's a number. And you can also choose how many places after the decimal. So you can click like this to have fewer places, click like this to have more. And now if you have 3 after the decimal, it will display your number like you want. You can also indicate these as a number by clicking on whichever cells that you're putting the numbers in, and then right-clicking and going to Format Cell down here. Then you can choose that it's a number, and you can directly choose how many decimal places here. But you can also use these buttons in the ribbon to do the same thing. One common thing too is to center the label here. You could center it. You could also bold it. It appears to be, oops, I italicized it. You could also bold it. It appears to be bolded here, which is nice. You can also put borders to separate things. So here, if you click here, it will give you all kinds of different borders. We could do like a thick bottom border to separate it if we like. That makes it look a little nicer. Yeah, as it says, do not include units in these. And then we're going to indicate a number, or we're going to be using a number of functions here to calculate some statistics. So the way that you make a function happen is you press equals, and then you put the function that you want it to perform, like count, and often it will tell you a list of functions that are like the one you have just used. And then if you click and drag around what you want to apply the cells you want to apply that function to, you can then press enter, and it will complete that and give you a value for the function. It's counting 2 because 2 of these cells have values here. It's a number of values. You can also use max, min. So I'll put one more value here. Let's say 1.360, let's say, or 260 rather. Notice that now, since I indicated that all of these somewhere down to here should be number with 3 digits, it did include my 0 this time. And then you can do equals max. If you do equals max and you pick whatever this whole range, it will return to you what was the largest one. Also, besides max and min, there's also large, and small. So if I put large here, then I have to put one more argument, and Excel will tell you this. It will say array. So array means the group of cells you picked, and then you should put a comma, and then if you put large 1, it will choose the highest value. If you put large 2, it will choose the second highest value. And small is like the opposite of that. And so is min. So if we want the smallest value equals min, and you just drag around this box here like this, and it will choose an array. You can see that the array is indicated by the number where the first, the cell where the first piece of data is, the first cell you chose, and then there's a colon, and it goes down to the second cell you chose. You can also do this crossways this way. So the A2 is the top leftmost cell, the B7 here is the bottom right, and it's indicating this entire region. And the lowest number here is 1.236. We can also do an average of the numbers, and the standard deviation, which is a measurement of how far apart they are. And so when you do this, you'd probably want to label these. So I can move this here, and you'll notice that it keeps my formatting even if I move this. And you might want to label for what you're doing here, so you can put that in a neighboring cell, like right here. We could change the width of the cells too, by if we go up here, if you go in between, it'll be this little bar with arrows. If you want the width of the cell to match exactly what's in it, you can go to the bar here and double click, and it will match it to the width of what's contained in there. So for example, let's say I want to write the standard deviation here. Notice that it has extended beyond my box, but what I can do is I can go up here and double click, and it will extend the box to include the entire range here. So what I'm doing here is I'm cutting. So you can do cut or copy. There are shortcuts for this. Cutting is Control X, paste is Control V, copy is Control C, and paste is Control V. So you can do this by right clicking it too. So what I'm doing is right clicking here, cut and paste, and then it puts it right down there. So I can do average right here, and what's probably useful is to right justify these. So you can go to alignment here and right justify in this way. That kind of looks nice. And then we can do RSD, or relative standard deviation. And I could right justify that as well. Here, and to do average, you do equals average, and then of course we select our range here, which is this, and that gives us the average. We can do equals std dev, not two D's, stdiv, which is standard deviation, stdev, and then we choose our range here, press equals, gives us a standard deviation, and then relative standard deviation is the average divided by the standard deviation rather, divide by the average. So what's indicated here, S is the standard deviation, the X with the line of it over it is the average. So we could do equals this number, the standard deviation, divided by, so notice I clicked this and it selected the box. Then I press the slash, which was divided. Then I can click the next box there, and it will automatically populate it with E6. So the cell is E6 here. That's the relative standard deviation. Usually we want this as a percentage. So the percentage relative standard deviation would be if we made this a percent, and you can do this in a couple of ways. I could copy this same thing here, and I could make it display as a percent. Whoops. And so, for example, this number, I can make it display as a percentage. If I go up here, there's actually a button there, percent style, and I can make it a percentage. Of course, you'll want to increase the number of sig figs. The percentage should have the same as the rest of yours. 4. So now I've made the RSD a percent RSD. So you can do it that way, or you can multiply the number by 100 to make it a percent. Either way. If you want to do parts per thousand, so RSD in terms of parts per thousand, PPT, that would involve taking this number and multiplying it by 1,000. With it times 1,000. Whoops. Must have made a mistake there. Equals this times 1,000. Oh, I put an X, that's why. Okay, instead of the X, make sure you use the star. So the star in Excel will be 1,000. I put the letter X because I've been typing in Word too much. The star means multiply in the formulas, and there you go. Whoops, sorry. I should have kept the regular RSD here. So I'm going to do again the regular. So just to make sure it was understandable, since I made a mistake here. The relative standard deviation, that's going to be the standard deviation divided by the average. If I display this in percent form, I get it here. If I want parts per thousand, I multiply the relative standard deviation times 1,000. Oops, I used an X again, but a star. Like that. And then make sure it's the right number of sig figs. It should be 4. So we should put this into number mode, and we can choose the number of digits to make it 4 right there. So parts per thousand is like percent. It's because percent is basically parts per 100. That's why you multiply by 100 to get it. Relative standard deviation, parts per thousand is, it's like percent, but instead of per 100, it's per 1,000. And that's the instructions that were just given there. And then for sig figs, yeah, again, keep the sig figs the same as for your average. Same number of decimal places. So for the mean, we want the same number of sig figs. For the standard deviation, we want the same number of decimal places. So I actually have too many for my standard deviation here. These have 3 decimal places, so my standard deviation should have 3 decimal places. So let's knock this down to 3. And this gives us 2 sig figs here on our standard deviation. So I should knock my relative standard deviation down to 2 sig figs, like that. And my percent standard deviation down to 2 sig figs, like that. And so on here. Unfortunately, Excel likes to leave off the decimal point. So this kind of looks like 1 sig fig, but it's got 2 sig figs. So the standard deviation will often have less sig figs than the average. Why is this? It's because, remember, there are different rules for adding and subtracting as there are for multiplying and dividing. When you calculate a standard deviation, it involves adding, and the place value is what matters here, the place value of your units. And so you make sure that the standard deviation has the same number of decimal places, the same place value as your original data. Okay. So if we're going back here, we're still in part A. So these are our mass measurements. We've got mass for 1.24 milliliters of water. So we're asked now to determine the density. Okay, so the density is going to be, let's say this is our average right here, and our volume. So our volume of water, just to put it on the side here, volume of the H2O. And by the way, if you want to have a subscript in here, you can actually highlight this and you can make it a subscript. It's a little bit more difficult than in Word. You have to right click here, format cells, and then choose subscript, like that. And now you can see that the 2 was made a subscript. So I highlighted it in here, I right clicked, I chose format cells, and then I choose subscript. And you can actually make a subscript like that. And this is in milliliters, and this will be 1.24. So obviously my numbers are going to be a bit different from yours because I didn't use all of these masses. But to get the density would be the mass over the volume. So the density here is going to be, and this is going to be, density will be in grams per milliliter. We're going to want to do equals the mass in grams, divide by the volume in milliliters. And then again, make sure these are numbers. So you want to put them into number format here. And then for density, our density will have 3 sig figs. So the way it's written is correct here, because our volume had 3 sig figs. Our mass had 4. Our average mass had 4. So we'll have a result with 3 sig figs here. So, and then it talks about entering a certain number of degrees Celsius. So we're supposed to be putting here density of water at so many degrees Celsius. So density of water, I'll just write water out this time since I showed you how to do the subscript, at, and now we have to put in a degrees symbol. So to do that, you go to insert and then you go to symbols, and this works in Word or in Excel. And you'll have a series of symbols here. So the way you'll find this is if you go down here to this box, you'll have a list of various things. You want the symbols. And so you'll have all kinds of different symbols. Mine, I use it so often that it's already there. And so, yeah, so we got a variety of different types of symbols here. And I think that you would find it under miscellaneous technical, probably. Yeah, right there. So that is the degrees. Let's make sure that it works. No, that wasn't quite it. I think that one's in the middle. That one doesn't look as nice. Insert symbol. And usually what I do is I just kind of scroll through this till I find it. But if you remember what group it's in, you know, you can do that too. This one here, symbol 176. It's from symbol decimals. So yeah, I'm sure there's a quicker way of doing it, but like I said, generally I just kind of scroll down through these till I find the symbol I'm looking for. And then once you've found it, if you're using the same computer again, then it will retain the symbols that you used before. So I could put insert there, and then it looks like a little degrees symbol. 4 degrees Celsius. Okay. Calculating percent error, I don't think I need to say a whole lot more about that, except to pay attention to your sig figs. Remember that your sig figs are different. If you add, the rules for sig figs are different when you're adding and subtracting than they are for multiplying and dividing. Look at the place value for those and to determine the last sig fig. So first consider the number of sig figs after you subtract, and then you will use the division rules. If you have questions about sig figs, let me know. You should be pretty good with sig figs now. So another thing that we're going to be doing very often is we're going to be, so I'll just clear that out. We're going to be graphing things. So when you graph things, Excel does a pretty good job of just figuring out everything for you. It's very nice. So in experiment 2 that you guys begin to do next week, those of you guys that are coming into lab on Tuesday, you'll actually, Tuesday and Thursday next week, group 1 and 2, you're going to be actually creating a graph like this. So this is a calibration curve. And so if I'm entering the data here, I'm just going to enter some, actually I probably could copy paste here. Yeah, I'll just show you guys exactly how this is done. So here I've just copy pasted the data in. Now Excel does not always label your graphs very well, even though it makes the graphs very easily. So I'm going to go ahead and graph this. So once you've entered your information like this, you select both the columns, then you press data, and then you press, oops, insert, and then you're going to get charts right here. You're going to get charts. The one you want is the one called scatter. It's right here. So when you click down on that, you'll have a few different options. What you want is the first one where it just puts in the dots. You don't want any type of connection, because that's not what we want. We don't want to connect the dots. What we want to do is find a trend line, which does not necessarily connect the dots. So one thing you're going to notice here is that on the graph that was made, so just to review again the way we did that, we highlighted our data. Okay, we clicked the insert on the top bar here. Then we went down in here to charts, scatter, it looks like little dots. And we chose the first scatter plot like that. And that's how you make it. Now, once we get this, clearly the labeling isn't right. It rarely is. So we're going to want to give this a title that is not just what's up there. We might call this, we'll call it the calibration curve. Or you could call it absorbance versus concentration too. That would be another one. Absorbance versus concentration. That would be fine. Okay. Remember, we write absorbance, which is the Y value, versus concentration. It's very common to write it this way. Now, you're going to be wanting to add some labels to your axes too. So here, we want axis titles. So you click the little plus here. You click axis titles like that. You could also right click and find these as well. So if I undid the titles here, I can usually right click the graph, and you can do various things here. If you want to make a title for one axis, you probably have to click that axis there. And there will be various options here. This is the way it used to be done, but now probably the easiest way. Format grid lines, there it is. So actually click the graph, right click. There's lots of ways that you can access these basically, but probably the easiest way is going to be to just go right here, click the plus, and go to axis titles. And this is one of those things that exists on the desktop version that doesn't exist on the internet version, and so you definitely want the desktop version to do this. It makes things much easier. So our y-axis is going to be absorbance, and absorbance doesn't have units itself, but a lot of people just say AU or absorbance units. And then you click on this box and you can highlight the text there, label this concentration, and make sure to include your units, molars, in parentheses there. And then the last thing we need is a trend line. And like most things, there's multiple ways to get to it. You can click the plus here and add a trend line, or you can click the data points and right click them, and you can choose add trend line. Either one of those is fine. If we go to trend line here, you'll see there are more options, like a linear. It's going to default to a linear, but even when you make the trend line, you're still not done, because you're going to want to add some other information. So let's go back to the right up there. So the information you're going to want to add is like the slope, the y-intercept, and a value called r squared, which tells you how linear your data is, how linear your trend line is, how well it fits the data, if it's linear. So what you do to get that information is you right click on the trend line, and what will come up is format trend line. You want to do that. Then you're going to look on the bottom in these trend line options here. You go all the way to the bottom. You want to click display equation on chart and display r squared value on chart. And that will give you the equation and the r squared value right there. So here you'll actually get the slope and the y-intercept straight from this from the chart here. It is also possible to use functions to determine the slope and the y-intercept and so forth. So yeah, so if you've got this and you do equals slope, and then you put the y's and the x's. So the known y's are here, the known x's are here, And we get the same slope that we had in the equation here. It's usually just easier to get it from the graph, but that's a way you could do it. And likewise, you could do the same thing to get the y-intercept. So equals intercept there. I should zoom in on this a little bit. Whoops, the wrong thing there, but it tells you, yeah, known y's here. So you'd select the y values, and then known x's, select those, and then it will tell you the y-intercept. That's the same as the y-intercept here, just more digits. And you could do the same with the r squared. So equals rsq. Again, known y's, known x's, and it will give you the r squared, which is the same as what's right here. Make sure not to include the value for the unknown. So for the unknown, I'm just going to give you guys a common unknown. I realized that I forgot to post that, so that will be coming up very soon. So I'll put that in there right now, right after I make this video here. So I think this just goes through what I just talked about, adding the linear trend line. You don't need the legend if it appears. It's not usually very useful. And then sig figs should follow the fewest number in the original data. So for example, here these all have 3 sig figs, so you don't really know any of this information to more than 3 sig figs. So if we were doing these, we'd want to limit them to 3 sig figs. We'd call them, you know, we'd go back to home here and make sure these are in the number format, and then we'd adjust the decimal places so that they're stated with the right number of sig figs, like that. And that's relevant here too. So this would be, you would round these. You have to do, on here you have to do it manually. So we'd have to write these as 11.2, and we'd have to write this as 0.00336, and this one we'd say 1.00. But I'm usually not too picky about the sig figs there. For the r squared, it can be a bit misleading, I feel like, to call it 1. It should be close to 1. Yeah. And so yeah, I'll go back to the unknown. So there's going to be unknown data that is similar to this. I'm just going to give everyone the same unknown. I just forgot to include that in here. I should have included it in the write-up itself. Okay, and so now integrated rate law. So we learned about that this week, integrated rate law. So I'm going to kind of walk you through here how to do a chart when you have integrated rate law here, or do a graph. And so I'm going to get rid of what I have here. Let's make a new sheet. And again, you would enter this data. I'm just going to copy paste it for time's sake. Make sure that everything is stated with the right number of sig figs. Again, you know, here, unless you put this into number form, it's not going to get the number of sig figs, and even then it's not aware of how many. It just defaults at 2 after the decimal. So we're going to shift this one so that it looks like 1 after the decimal, like this, and we're going to shift this one so that it goes 4 after the decimal, so the data looks, not 3 after the decimal, so the data looks correct at this point. So remember that there are 3 graphs that you're going to be making when you're doing integrated rate law. One of them is going to be concentration of your reactant, concentration of A versus time. If that is linear, that indicates a 0 order reaction. To know if you have a first order reaction, you'll want to graph the natural log of the concentration of A versus time. Okay, and so to get that, we do equals, and then we type ln, and we open the parentheses, so it's like any other of these functions we're using. Then you just click on this. Now here's where I'm going to teach you a neat little trick, where if you have a series of data like this, you can get it to do the same thing to all of them. You can either use, so there's a little box here, I'm going to zoom in so you can see it better. There's a little box on the edge, and if you drag that and pull that down, it will apply that same function or formula to the data right next to it, and it will follow that down. So this one references B2, this one's referencing B3, B4, B5, and so on. And then even further, if you double click on that box, it will fill all the way down to where you want it to end. So that one thing is, when we're doing the natural log of a number, it should have the or any log, it should have the number of decimal point places that is equal to the number of sig figs in what you're calculating here. So we should reduce the number of decimal places to, most of these have 3, so I think it's appropriate to do 3 there. And now finally, so this is, we'll graph this versus the time to see if our reaction is first order. Next, we want to do 1 over the concentration of A. Now you'll notice I didn't put units here. It's hard to say what the units of like natural log of molar would be, but for 1 over concentration, clearly your units are 1 over molars, or molars to the -1 power. And I can make that a superscript here. So I highlight it, the -1, I right click, format cells, click superscript. And so then that looks nice and neat there. And then for this one, I will do equals 1 divided by the concentration, like that. I click on it. And again, you can get this to go all the way down if you double click it. And then make sure that it has the right number of sig figs, which should be, I guess it would be 4 for this one, but the rest are 3, so I'll just keep it to 3 here. So these are make sure these are numbers. Right? These should be numbers, and we want the right number of sig figs here. Here it should be 3 after the decimal. Here it should be 3 sig figs for all values, technically except for the first one, but. And there we go. So now we have our data. I'm going to make these all bold. I press Control B. You can also click here, bold, centered. And then I'm going to make a nice border for everything. I can do here, all borders. That's fine. So I click this little box, all borders. And then maybe you can even put a thick border underneath if you like that. The borders don't really matter that much. And I think I'll make these all the same font too, so they look nice. Okay, and so now we're ready to graph. And the way you graph is the same as I showed you before. There is a little trick to selecting columns, so you could copy these columns out somewhere else. If you do copy this, you want these numbers, but you want them copied somewhere else, you can copy them. But notice if I copy here and then I put it like over here, if I just press paste, like Control V, it's paste, it will keep the references to being to the cell right next to it. So what you'll want to do instead is, if you're copying to somewhere else, you'll want to copy and paste the values, which will keep the values there. You'll still have to deal with the formatting. You could just copy, and you can also paste the formatting like this. So if I right click it, this here pastes the formatting, and then it makes the formatting the same too. Okay, Next, we want a graph. And so, like I said, you can move these around. Like you could make, if you wanted to make another column, let's say you wanted to do this, and you wanted to put your Y values over here, so you could easily select them. So I did copy, and then I did paste values, and then I did paste format. I could do that, and then I could simply select them and make a graph. But I'll show you ways you can select directly from here. So that would be doing it just like we did last time, where we only had two copies of two columns of data. But here so if we have two columns of data like this, that's very easy. So we just highlight the whole thing, and we choose insert, and we choose scatter, and we choose these points, and you'll notice it does not look very linear. We'll want to change the title here. This is going to be concentration versus time. And then we'll want to add our axes titles. We'll want to add our trend line. And what you'll notice is if we put a linear trend line, this clearly isn't linear. To further emphasize that, we can do format trend line, right click. So you click on the trend line, right click it, format trend line, display equation, display R squared. And the R squared is not close to 1 here because clearly this is not linear. This is not linear here. Now I'll show you how you can select two columns if they're not right next to each other. So the key to doing that is you click one column, then you click the other one while holding Control. Okay, and now you can see I've clicked two columns that are separate. The other way you could do this is you could right click the top and you could hide one column, and then you could just select these two. Of course the graph went away for a second because I hit it. Then I can unhide. So then you can select the columns around it, right click, unhide, and now this graph is appearing again. But personally I like to click the column, or you can drag across the numbers themselves here, hold Control, and then click the rest. You can either click the whole column, hold Control, click the whole column, or you could drag it. Then we'll do the same. Insert, scatter, boom. And we've got this right here. We'd do the same. We'd title it. We'd put the axes labels. I'm not going to do that. I'll make sure I put a trend line, and then I will right click the trend line, format trend line, display equation, display R squared. And the R squared is like 1 here. It's perfectly linear. Do the same thing for the 1 over the concentration. So again, select those two columns, either drag your column or select the whole thing if you have nothing underneath. Hold Control, click the other one. I don't think there's a visual way to do that. You have to use your keyboard to do it, unless you hide the columns in between. Then you can determine the rate constant. So as you can see here, you probably tell it was natural log of A versus time was linear, so reaction order 1. The rate constant is a negative of the slope, so it's a negative of negative 0.0013. So the rate constant would be 0.0013. You use the slope there. And then here's another example where we're going to make a graph. So those are these are the values that you will use, and the slope here will be equal to what's called the activation energy over the gas constant, 8.314 joules per Kelvin. Now I'm going to leave it to you to do this graph just the same way we did. I will say that this is the way that you're going to solve for the activation energy. I'm just going to write this. You'll want to do it on, by typing in equations like you've seen previously. So here, our y is going to be the natural log of k. So make sure it's the natural log of k that you're going to be plotting on the y-axis. So make sure to get the natural log of k. You'll need another column here, and you'll type in equals ln, and then you'll choose this one, and you'll get the natural log. On your x-axis, you're going to need 1 over temperature, but this temperature has to be in Kelvin. So you're going to have a couple steps here. Convert the Celsius temperature to Kelvin temperature. And then you'll get like this is 204 plus 273. Okay, that's going to be your Kelvin temperature. And then you're going to do 1 over your temperature. So this is going to be equals 1 divided by what's right in here. Then you should have 2 columns. Okay, so your 2 columns are going to be 1 over the temperature, which is going to have units of Kelvin to the -1 power. And you're going to have another column. Move this over a little bit. And you're going to have another column that is going to be the natural log of k. And you don't have to say units for that since it's natural log. And these are going to be what you plot. This is going to be your x values here, 1 over temperature. This is going to be your y values right here, natural log of k. So you're going to plot those. So your y is going to be natural log of k. Your x is going to be 1 over temperature. Your slope is going to be the activation energy over the r. This is r. So you're going to have the slope, and you want activation energy. So you'll want to multiply both sides by -r. -r. That's going to cancel your negative. You're going to cancel your r. And you're going to get, in the end, that the activation energy equals -r times the slope, which you will get from, your slope is going to come from your graph. Okay. Now this is the hardest part, the last part. I don't want to show you everything, so I'm giving you a little bit of independent work here. This is a nice little kind of mini introduction to what we'll be talking about next week too. And so for your unknowns, again, I'm gonna give you the unknowns. I need to post them. I forgot to post them, but I'll post your unknowns and you'll be able to get that done as well. And so I hope this video helped. If you have questions at the Thursday office hour, let me know. And yeah, good luck with this assignment here.